hell am I doing here? Where am I? Hello?
Welcome to Wonderland. Let's have some fun. Your task is to find the tea party. See you there.
Hey, where are you going?
Look, first clue. Dang, this is hot. Wait, I found a note. Use the data in the table to approximate the rate at which the temperature of the tea is changing at time t 3.5. Show the computation that lead to your answer. What's this supposed to mean?
Good job. I see you found the first clue. This is the first step in you finding the tea party. See you there. Don't be late.
In order to find the rate at which the temperature is changing, we must find the derivative. The derivative can be found by finding the slope. So we find the slope between t equals 2 and t equals 5 to find the rate at which the temperature is changing at time t equals 3.5. To find the slope, we use the equation m equals y2 minus y1 over x2 minus x1. Then we plug in the numbers from the chart, 52 minus 60 over 5 minus 2, which gives you the slope, negative 8 over 3.
Where's that ugly guy at? Hey, there's another clue. Using correct units, explain the meaning of 1/10 of the integral of 0 to 10 ht dt. In the context of this problem, use a trapezoidal sum with 4 intervals indicated by the table to estimate 1/10 of the integral of 0 to 10 ht dt.
I see you're a clever boy. You found my next clue. See you at the next stop.
1 over 10 times the integral from 0 to 10 of ht dt is the area under the curve. Since the function is not given, you find the area by using trapezoidal sums. The trapezoidal rule is defined by the equation t equals base 1 plus base 2 times height over 2. T1 equals 66 plus 60 times 2 over 2 equaling 126. T2 equals 60 plus 52 times 3 over 2 equaling 168. T3 equals 52 plus 44 times 4 over 2 equaling 192. And T4 equals 44 plus 43 times 1 over 2 equaling 43.5. When added together, they equal 529.5. After adding up the trapezoidal sums, you divide by 10 to find the average value of the temperature of the tea in degrees Celsius from time t equals 0 to t equals 10. 529.5 divided by 10 equals 52.95.
Man, I'm about to beat this guy up. Oh, I found another clue. Evaluate the integral of 0 to 10 h prime t dt using correct units. Explain the meaning of the expression in the context of this problem. What's that supposed to mean?
The challenges are only getting harder. You're almost there. Catch up if you can.
The fundamental theorem of calculus part 2 states that if a function is continuous on the interval a to b, and if f is any antiderivative of f, then the integral from a to b of f prime of t dt equals capital F of b minus capital F of a. Using f-talk part 2, the integral from 0 to 10 of h prime of t equals h of 10 minus h of 0. The values of h of 10 and h of 0 are given in the chart. 43 minus 66 gives you negative 23. Negative 23 degrees Celsius is the amount the temperature of the tea has changed over the interval 0 to 10.
Man, I go to work. True winner. G skinny like squid.
Man, I'm tired of this guy. Heck is he? I think I found another clue. At time t equals 0, biscuits with temperature 100 degrees were removed from an oven. The temperature of the biscuits at time t is modeled by a differentiable function b, for which is known that b prime of t is negative 13.84 e to a negative 0.173 t. Using the given models at time t equals 10, how much cooler are the biscuits than the tea? That's confusing.
You made it to the last and final clue. You're almost there. Aren't you excited?
Forget that. I'm not chasing you anymore.
Given b prime of t, you integrate the function to find b of t, which is the temperature of the biscuits at time t. You then add 100 since it is the initial condition. To take the integral from 0 to 10 of b prime of t dt, you take the integral using your graphing calculator. Steps to take the integral. Press Math, press 9 or scroll to F and Int, press Enter, put in the equation negative 13.84 e to the negative 0.173 t. Then add a comma, x, comma, 0, comma 10, parentheses, and press Enter. Your calculator should now look like this, but don't forget to add your initial condition, so add 100. Next step, find how much cooler the biscuits are than the tea. Find the difference. Subtract h of t minus b of t at t equals 10. Refer back to your chart. Subtract 43 minus 34.1827, giving you 8.8173. The biscuits are about 8.817 degrees Celsius cooler than the tea at time t equals 10.
Bang this, big up to my bro Sam, he the king of this. Call me SpongeBob, Krabby Patty. Check out the art. Do my cat.
Where the heck is everyone? Hey, there's a tea party over here.
You made it! No, peace and love, peace and love. Please, have a seat. Come join us. Have some tea and biscuits. Please.
Is this food? I think it is.
Guys, we just finished the AP test.
In order to find the rate at which the temperature is changing, we must find the derivative. The derivative can only... Oh, crap.
Welcome to Wonderland. Let's have some fun. Welcome to Wonderland. Let's have some fun. So you...
That's pretty cool. Like, there's an option where you can
Oh, there's a note. Did I read it? DT.
You're a good one, I see. I see you found the next clue. See you there.
Anytime now.
So, do you guys know the answer to this question?
Yeah,
buddy.
You ain't been the same. Not saying I'm the richest man alive, but I'm in the game. As long as you keep it 100, I'ma spin this chain. Whenever you need